We have given sets A, B, and C, and in this example we have to find the symmetric difference of sets B and C. So first let me remind you the definition. The symmetric difference of sets B and C consists of those elements which belong to B or C but not to both. So let me write this, that symmetric difference of sets B and C is all x's such that x belongs to B or x belongs to C but not to both. So next, let me copy set B. We need to have set B 1, 2, 3, 4 has elements. And we need set C. We see that set C is all positive integer. Z plus means positive integers. And we know that all the numbers are used for counting are positive integers. And these numbers must be odd. So we know that any integer that cannot be divided exactly by 2 is odd number. So we need to have positive integer and odd. So it will be 1, 3, 5, 7, 9, 11, and so on. So now when we have to find symmetric difference of the sets B and C, we have to put all numbers from set B and from set C, and we cannot put numbers which repeat. So we have 1 and 1, so we cannot put. Next we have 3 and 3, 2 and 4, we don't have it in set C. So the symmetric difference of sets B and C will be, we have 2, 4, 5, 7, 9, 11, and so on. So this is my solution.